So in this section, we're looking at the formula for surface area of a solid formed when we take a function and rotate it around an axis. Okay, so not volume, but surface area. And we're going to approach it the same way we did with everything else, where we sketch it and we look at a slice, we figure out how to label one slice, and then we write an expression for the whatever area, in this case it's going to be circumference, of a slice, and we integrate that. Okay, so we are looking at the function y equals root x. Okay, so y equals square root of x, something like this, between x equals 15 over 4 and 35 over 4. Once again, not the best fractions, but there's a reason it's going to work out nicely. So 15 over 4 is just a little bit less than 4, and 35 over 4 is just a little bit less than 9. So I'm going to say this can be 15 over 4, and this can be 35 over 4, sure. So here is our region, and we are rotating around the x-axis. Okay, so when we rotate, we start by reflecting, so somewhere around there. Okay, not bad. And then we add the roundness. With squish circles, something kind of like that. Ooh, it's a little bit wonky. Let's just see if I can do it better this way. That's a little better. Okay. All right, and I'm going to draw one slice through the middle. Okay, so this is what I'm looking at, and I'm going to try and label this slice. Okay, so what shape is one slice? It looks very much like a disc when we did volumes of solid of revolution. However, we don't actually care about the full solid. We are just looking for the outside of that, which is a circumference, okay? So we still have this disc, okay? And we have a radius that's equal to the function, so root x. However, this thickness is not dx, because now instead of the thickness being just from here to here, the thickness is along the curve at an angle like this, okay? And if we think about what we did with arc length, we know that that is, we could represent it as like ds, if we're using s for arc length, okay? And that becomes this thickness. And so we're talking about the circumference of one circle, which is 2 times pi times the radius. So 2 times pi times, in this case, root x. But the thickness is ds. So we're going to integrate it. First, we're going to write it with respect to s, okay? So this is our circumference. And really, we could write this as a function, c of x, okay? All right, so then to figure out the total surface area, that's going to be, actually, let me go over here, give myself more room. So that total surface area is going to be, and I'm going to move that 2 pi to the front. So 2 pi times the integral of root x ds from, so 15 over 4 to 35 over 4. But ds, we need to rewrite with our, or the integral of ds, we need to rewrite with our arc length formula. Okay, so that becomes 2 pi times the integral from 15/4 to 35/4 of root x times root 1 plus, and then this is where we're going to do our derivative and square that. Let me fill that in a second, and then times dx. Okay, go back to the arc length video or notes if you don't remember the arc length formula. Okay. And so this right here is the derivative of our function. Our function is y equals root x. So that means that, I'll go up here. Try not to change colors because it's a little glitchy when I do. So try and do it all in green. Okay, so y prime is equal to 1/2 x to the negative 1/2. And so that is going in here. So didn't leave myself much room. X to the negative 1/2 over 2. Make that a little bit bigger, okay? So let's simplify this a little bit. So we have 2 pi times the integral from 15/4 to 35/4 of, and I'm going to distribute a root x. So I end up with x plus, and then this squared is, let me just move this part over, is going to be x to the negative first over 4. But then I'm multiplying it by x because that x is also under a radical, so then I just have a 1/4. I don't need that whole thing. Okay, dx. Okay, and then that I can integrate pretty quickly, except I'm going to cheat and give myself more room here because I didn't plan the space well. Okay, so I'm going to switch colors. Let's hope it doesn't fritz. Okay, so this is my u, the inside of the composition. Du is just 1 dx. And then I also need to plug these both into u. That's why I have something over 4, because I'm going to add 1/4 to it. And I'm going to get some nice whole numbers. So 2 pi times the integral of u to the 1/2 du, and then 15/4 plus 1/4 is 16/4, which is just 4. And then 35/4 plus 1/4 is 9. Okay, so then integrating, I have 2 pi times 2/3 u to the 3/2 from 4 to 9, which is 4 pi over 3 times 9 to the 3/2 is going to be 3 cubed, so 27, minus 4 to the 3/2 is 2 cubed, so 8. And then I have 27 minus 8 is 19. 19 times 4 pi over 3 is 76 pi over 3. And there's my surface area. Okay, here's a generalized formula. Again, very similar to the arc length formula, which is all of this part right here, actually with the dx, but we are adding this right here because, and the 2 pi, because we are doing 2 pi r times arc length. Okay, and the 2 pi r is 2 pi, and then that's my r, and then all of this is arc length. Okay, all right, I'm going to pause it and do one more. You do it as well. Try, see if you get the same thing I do. Okay, that's what I got. I hope you did too.